All right, Yuri's here for this one. I just did a take, and I was saying all the months wrong. So let's see if I can do it right this time. Got the path of the sun. The sun rises when I eat my breakfast feast. The sun's rising in the east. Okay, now that's kind of true. This right here, this would be like March 21st or September. Okay, both of them are the 21st. It rises due east, and it goes up, 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 up till about noon, and then it sets. You get your rest, the sun sets in the west. Okay, it's pretty straightforward. If the sun rises at 6 a.m., this would be like 7 a.m., 8 a.m., 9 a.m., 10 a.m., 11 a.m., and noon, and then 6 more hours. So you have 12 hours of daylight on the equinox. Okay, that's a medium length sun path. Okay, now let's say this is September. October, the path of the sun is going to be about there, and it's going to go up and back down. It's a little bit shorter of a path. The days are getting shorter. November, the days are getting even shorter in November. The sun path is always going to be a parallel line, okay? But in the November path, it would look something like that. See how that's parallel to the next one, which would be December. December 21st, shortest path of the year, shortest day of the year, lowest sun of the year. Okay. Now, if you take your happy earth science student, look at they're smiling because they're an earth science student and they're happy. That earth science student is looking to see the sunrise. They're not looking directly east. Because the earth is tilted, the sun's location changes a little bit with the seasons. That right there is southeast. So sunrise in the wintertime is southeast, and then it sets somewhere in the southwest. You put lunch in your mouth, the sun is always due south. Okay, so December, and then January is back here, February, March, April's sunrise is going to be something like that, May, and then June, and June's the longest sunrise. So all of the rises are somewhere towards the east, but in the summertime it rises north of east, and it goes up here, and then it sets north of west. Okay, and if there was a little mark, say right here, what time of day would that be? I'm not 100% sure, but I know that if this is noon, my best guess would be something like 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock at night. Okay, and there's more than 12 hours of daylight. In the summer, that path is a lot longer. So this would be like, for Rome, it's somewhere around 15 or more than 12. And for here, for Rome, it's somewhere around like 8.5 or 9 hours of daylight. Okay. Now, these paths are always perfectly parallel. Okay. That parallelism, I don't know if that's a word, that parallel nature, for one location, it's always parallel. When you look at these diagrams on the screen, like any of these are for different locations. So when you see the angles tilting, location A, this is something like on the equator. Location B, this is September 23rd, first day of fall, okay? This would be for something like Rome. Location C, do you see how the sun is just going around the sky constantly? It doesn't even set. That's so far north, that's probably in like northern Alaska or, yeah, probably northern Alaska, somewhere like that. The sun doesn't set. And then location D on March 21st, do you see how the sun isn't south when you put lunch in your mouth? This would be like in Australia. The sun is north in Australia. So that's the only time that that can happen in the southern hemisphere. Okay. The more common diagrams that you'll see are something like this, where the sun rises in the east and sets in the west. Sometimes they'll flip the diagram and put the east on the far side. That just makes it more confusing. But it's all the same thing. On March, it rises due east and sets due west. All right. Hopefully that makes sense, and we will revisit these diagrams with the next video, going over how the shadows look during the day too. Just got to figure out how to turn this off.